In this edition, we will learn about lightning detail. If a lightning strike happens instantly, why does it appear to linger for a second or two? A lightning strike doesn't happen instantly. As with all physical processes, it takes time to complete. Much of the lightning forming process is invisible to the human eye. You only notice the spectacular discharge, and by human standards, that does end pretty quickly. Let's walk through the steps of lightning formation. There are multiple types of lightning, which includes cloud to ground to cloud, negative lightning, positive lightning, so-called ball lightning, which may not be actual lightning. For the purpose of this discussion, we'll focus on negative cloud to ground lightning, which is probably most people's common idea of lightning. Lightning happens when there is a great separation of electric charge between two regions. In the case of negative cloud to ground lightning, there is a buildup of negative charge in the base of the cloud and positive charge on the ground. Because opposite charges attract, the negative charge in the cloud wants to move across the gap towards the positive charge in the ground. However, air just isn't a very good conductor of electricity. So, the charges builds and builds until it reaches a critical value called the dielectric breakdown constant of air. This is the level at which air breaks down and becomes electrically conductive. When this happens, air molecules literally break down into positively charged particles called ions and negatively charged particles called electrons. At this point, electricity can flow through the air. Lightning, but it doesn't happen all at once. Starting from the cloud, the air becomes electrified in short segments called stud leaders. Each leader is about 50 meters long and lasts about 50 microseconds. As the charged channel reaches towards the ground, it may fork. The channel doesn't know what it's going to strike. It is just looking for the path of least resistance, so to speak, and will branch repeatedly until it forms a conducting pathway to the ground. Meanwhile, a positively charged channel starts to form from the ground. This is known as an ascending leader or positive streamer. When the stepped leader connects to a positive streamer, it creates a conducting channel from the cloud to ground. At that point, the entire charge travels through the channel in a series of short pulses. Each pulse lasts 60 to 70 microseconds and the entire charge drains in about a fifth of a second. The rapid movement of energy causes the surrounding air to heat up and expand violently, almost like an explosion. This exploding air causes a sound of thunder. Once the charges has drained, the air molecules recombine and the air is no longer electrically conductive. However, if the processes that created the electric charge are still at